Today we're looking at notes 2-4 part 2, transform absolute value functions including the horizontal stretch, shrink, and reflect. So this is our recap of part 1. So remember in part 1, we did left and right shifting, we did up and down shifting, and then all we did in part 1, 2-4 part 1, was vertical stretch, shrink, or reflect, okay? And that was dealing with the A value. So probably whenever we dealt with this assignment and this notes, you probably were like, why does this go A, C, and then D? All right, well now you know why, because we were skipping the B because it is a little bit more difficult, so we kind of put it off. So the B will deal with your horizontal stretch, shrink, and reflect. Now like A, remember A was our vertical stretch, shrink, and reflect. Remember how A changed the points on the table? We multiplied the Y values by A because that was a vertical stretch, shrink, or reflect. That's why we did Y, because Y is vertical. Similarly, B changes the points just like A changed the points. So B changes the points on the table. We will multiply our X values by 1 over B. And so you'll see that theme a lot as we deal with the horizontal stretch, shrink, and reflect. So you're going to see that we're going to multiply by 1 over B, or when you were describing it, we're going to say by 1 over B, or in other words, the reciprocal of B. And that should kind of make sense to you because going back to this 2-4 part 1, remember that the numbers, the values inside the absolute value bars, anything inside the absolute value bars acts opposite of your intuition. What I mean by that is, remember here, that -2 actually shifts the graph right 2. So when we deal with values inside the absolute value bars, like that -2 shifted the graph right 2, and like that +3 actually shifted the graph left 3, how that was kind of opposite of intuition. All right, so like I said, when you deal with values inside the bars, it does kind of act different than you would think, and hence the 1 over B. And I'll kind of get to that and explain that more here in a minute. But let's go ahead and talk about these real quick. So if you take this value B, whatever it is, like here it's 2, here it's -1, here it's 1/2, here it's 4. If you take the value B and you take the absolute value of that value, I know that's a mouthful, okay, then examine whatever that value is, and that'll tell you what's going to happen. If that value is greater than 0, you'll have your horizontal shrink. I know that seems so backwards. Greater than 0 is going to cause a shrink by 1 over B, or the reciprocal of B. Okay, if that value lies between 0 and 1, then that'll be your horizontal stretch by 1 over B, or the reciprocal of B. And then if that value, and of course here you're not taking the absolute value of that value, you're just leaving it alone. If that value is less than 0, then that'll be your reflect over the y-axis along with any horizontal stretch, shrink, or reflect if applicable, okay? So now let's get to our examples. So number 1, graph the given function and state the transformations from the parent function. So again, I don't have any A, C, or D. I just have a B value here. Okay, so no left or right shift, no up and down shift, and no vertical stretch, shrink, or reflect. All I have is the B. So what does that B value do? So remember, take the B value, which is 2, and then it's not negative, so take the absolute value of it. It's still +2. And so +2 is greater than 0, so the absolute value of B is greater than 0. So that means we're actually going to have a horizontal shrink. I know it's weird. I told you it acts opposite of your intuition. We have a horizontal shrink because of the 2 and because it's greater than 0, and it's a horizontal shrink by 1 over B. So that would be 1 over 2. So that does kind of make sense. It's a horizontal shrink by 1 over 2, right? So again, like we said before, we're going to take those X values and multiply it by the reciprocal, so by 1 over 2. So that's why you can probably see why I left the space here when I made my table. So these are the original coordinates for our absolute value parent function. I'm going to take my X values and multiply them by 1/2. So -1, -1/2, 0, 1/2, and 1. So I'm going to cross out my original X values. And from my origin, because I didn't shift, it's just the true origin, plot these points. So -1, 2, -1/2, 1, 0, 0, 1/2, 1, and 1, 2. And y'all remember, I've got to see all 5 of those points. I've got to see your table for sure. I definitely don't expect you to do this in your head. I don't want you to do it in your head. Okay? I need to see your table, and I need to see all 5 points and straight edge and arrows on both ends, just like we've been doing all along. Okay, so there's that. And then let's talk about it. Does that look like a horizontal shrink? Yes, we took that graph and we horizontally shrunk it or compressed it. Okay, now let's look at number 2. So in number 2, our B values, maybe I should be writing this so you kind of know. Our B value here was 2. Our B value here is -1. So remember, when our B value is less than 0, that's a reflect over the y-axis. And I'm still going to do exactly what it says here. B changes the point, so multiply x by 1 over b. Well, b is -1, and 1 over -1 is still -1. So I'm just simply going to multiply my x values by -1. So -1b, or really I can just write -1 times x, so just really -x. Okay, so multiply each x value by -1, so that's +2, that's +1, that's 0, that's -1, and that's -2. Because remember, I was multiplying all of my x values by -1. All right, and again, my origin didn't shift, so I'm just simply going to do 2, 2, 1, 1, 0, 0, -1, 1, -2, 2. Huh, fancy that. Looks just like the absolute value parent function, doesn't it? Yeah, because think about it, y'all. The absolute value function is symmetric. The absolute value parent function is symmetric about the y-axis. And every single absolute value function is symmetric about the vertex, right? It's symmetric about this vertical line here. So of course, when I reflect over the y-axis, nothing's going to change. Now my points, they did go in a different order, but it still was essentially the exact same points as the parent function. So quite interesting, isn't it? So your reflect over y-axis for absolute value graphs won't change anything for any of your absolute value graphs. But it's still, you still have to write it and you still have to do your table. Because when we get to the other functions, some of them it will affect, so you need to get used to it. Okay, used to the process is what I mean. Okay, so our B value in this case is 1/2. We don't have an A, a C, or a D. So again, no left, right, up, down, vertical, stretch, shrink. So I'm gonna go ahead and start this part. I'm gonna multiply, remember, we're gonna multiply our X values by the reciprocal of B, or 1 over B. Okay, so in this case, we're gonna multiply our X values by 2. All right, and let's talk about what the transformation would be. So if you take that B value, take the absolute value of it, it's not less than 0, so it's not a reflect. If you take that B value, you take the absolute value of it, so that still would be a 1/2. All right, that lies between 0 and 1. So that's your horizontal stretch. Can you see it? Horizontal stretch by, remember, that's my horizontal stretch by 1 over B, or the reciprocal of B. So I would say that's a horizontal stretch by 2. Okay, so here's where you have to be really, really cautious. So when you get your B value, after that, you don't really do anything with it other than use that to examine what you're going to have here. But otherwise, you'll notice once you get your B value, you always reciprocate it here in the table. You always reciprocate it here for your words. Okay, in this case, none of that really needed to be done. It did, but -1, when you reciprocate it, it's still just -1. That's why it was the same here. And when you say reflect, you don't need to put a value there. But here you'll notice, just like this problem, when you have that B value, you reciprocate it, and that's what goes here, and that's what goes here. Okay, so you got the B value, and you reciprocate it for here and here. So just want to really ingrain that in your brain. All right, so now I've got my horizontal stretch by 2. Let's go ahead and multiply my X values by 2. So -4, -2, 0, 2, 4. So -4, 2, 1, 2, 3, 4, 2, and negative 2, 1, 0, 0, 2, 1, and 4, 2. Okay. So does that look like a horizontal stretch? Yeah, we can come over here and look at, remember that's the same as the parent function. We can come over here and look at that and say we took this and we horizontally stretched that out. So that makes sense. All right, last example of this type. So on this one, we do have an A value. Remember that's our A. This is our B, and this is our D. We don't have a C, okay? We have an A and a D. We don't have a C, but we have a B. So I'm going to go ahead and write out like I have been all along. Our B value is 4 because that's the one that's funky. All right, so I've got the B value. Let's go ahead and list the transformations first. Yeah, that's what I think I want to do first. So remember the A value here, that deals with vertical stretch, shrink, and reflect. The B value deals with the horizontal stretch, shrink, and reflect. So this is our vertical reflect, and remember that's actually your reflect over the x-axis, okay? Because that would change the points vertically, if you know what I mean. Okay, so that's our reflect over x-axis. So that A value made us reflect over the x-axis. This B value of 4 here, remember that's going to be a horizontal, what's it going to be? No pun intended with the B's. That's going to be a horizontal shrink by a fourth, and that makes sense because remember we reciprocate this value, and that would make sense that it's a shrink since it's a fourth. Okay, a horizontal shrink by a fourth, and then up 5. Remember the D makes it move up 5. So I am going to go ahead and move my origin up 1, 2, 3, 4, 5. I'm going to go ahead and do that real quick. Move my origin up 5. I hope this graph goes down, right? Otherwise we don't have space. Oh, it does, doesn't it? So I need to multiply my x's and my y's. So let me be really, really clear. And all my people who aren't listening right now are really missing out. And uh-oh, that's not going to be good, okay? Here, I'm going to scoot this over a bit. So if you have any b value other than 1, if you've got any b value other than 1, y'all, like I was saying up here before on number 1, I've got to see this table. Like, I've got to see it. I know whenever we did 2-4 part 1, and whenever you got used to it, you probably could do all of these that had the a values. You probably could do these in your head. You probably could, okay? And I would have been okay with that. But now that we are incorporating this b, and especially when it's going to get more difficult and more hard, I've got to see the table. So I'm just letting you know now I've got to see the table. So remember, I'm going to take my x's and I'm going to multiply them by the reciprocal of b. Those two values there should match, and they do. Okay, and then my y value needs to get multiplied by the a. Okay, so negative y. Okay, so my y value gets multiplied by the a, and my x value gets multiplied by the reciprocal of b. So are we good there? Okay, so let's take this value. So a fourth of negative 2 would be negative a half, and then this would be negative a fourth, and then 0, a fourth, and a half. Cross that out and done with that. Then this would be negative 2, negative 1, 0, negative 1, negative 2. Cross that out. So look at that. I'm not plotting anything that's original. It's all new. Okay, so left a half down 2. Left a half down 2. Left a fourth down 1. That's really tiny. Okay, 0, 0. Right a fourth down 1. And then right a half down 2. So that's super duper tiny, isn't it? But y'all got it. Sure, it looks great on your paper. Whew. All right, there we go. So did it reflect over the x-axis? Certainly. We can tell that from the parent function it reflected over the x-axis. Did we horizontally shrink or compress? Yeah, we did. We definitely did. And then we moved up 5. So it looks great to me. Okay, last portion of the notes. So state the vertex and axis of symmetry of each graph Then write an equation for each graph. So vertex for this graph, that's easy. It's 1, 2, 3, 4, 5, -1. So therefore my axis of symmetry would be x equals 5. Okay, how do you write the equation? Well, that's a great question. So of course your vertex, that's the easy part. This is going to look like x minus 5 minus 1, remember? Because we want it to go right 5, so we've got to put the minus 5 there. Okay, so that moves it right 5 and down 1. So there we're good. Then whenever you write these equations, for now, until we get more professional at this, I will say, I never want you to give a b value. I never want you to give a b value here, okay? If there's a stretch or a shrink, I want you to consider it as vertical, okay? So always look at the stretch and the shrink and apply that to the a value here. I promise our lives will be much easier if we do, for now, okay? At least for now, while we're still beginners at this. So what I'm going to do is I'm going to examine, is there a stretch, shrink, or reflect? The reflect question is easy, it's a no. Okay, is there a stretch or a shrink? Well, I'll know that by, remember, this is the same as the parent function. The parent function goes up 1, right 1, up 1, right 1, up 1, right 1, or up 1, left 1, up 1, left 1. So let's examine that. Does this graph go up 1, right 1? Yes, and up 1, left 1. So there's no vertical stretch, shrink, or reflect, so the a value is 1. We're just going to leave it like that. So we're good to go. That's that equation. Okay, let's look at this one now. So our vertex is the ordered pair 1, 1, 2, 3, 4. So 1, comma 4. So therefore our axis of symmetry is x equals 1. So on this guy, we know for sure we're going to have an a value because it at least reflected. So let's fill in this part at least first. So this shifts the graph right 1, up 4. Is that correct? Yes, it is. Okay, so remember opposite on the x value. Then I know it's reflected over the x-axis, so I'm at least going to put a negative for sure. And then think if the original, the parent function was reflected, the graph would go down 1, right 1, down 1, right 1, down 1, right 1, or down 1, left 1, down 1, left 1. Let's see if that's what's happening here. So am I going down 1, right 1? No, I have to go down 2 before I can go right 1. I have to go down 2 before I can go right 1. So therefore my vertical stretch is by 2. I promise if you just think about it as a vertical stretch or shrink, it'll be so much easier than dealing with horizontal stretch or shrink. So for now, like I said, if there is some kind of stretch or shrink, let's just make it vertical. And it's kind of cool and an interesting conversation that we can all have at some point when we get better at this, that your vertical and horizontal stretches and shrinks and how they act and how they change the graph. So we will have those conversations at a later date.